Okay. Oh, hi. My name is Ceren. Today I will be talking about regenerative food systems. I am not an agricultural specialist. I'm not also a food specialist, but I am a designer, and therefore we will be talking about some insights of a designer's perspective. First, I would like to talk about my journey. I have lived and worked and studied in several continents and locations in the world, and therefore I claim the world as my home place. And following a passion on designing for healthcare, I found also myself in Eindhoven in the Netherlands, designing healthcare products, and medical products for hospitals for the last 8 years. And here in the high-tech campus, I have also found a new passion in life, which is beekeeping. I've been keeping bees at the high-tech campus with my other two beekeeping colleagues. We name ourselves High-Tech Honey. And we've been working, having fun and working hard to create the awareness on the bees themselves and their importance as pollinators for the food crops. And we've been also working on the awareness of local food produce by organizing some honey tasting events. We did some honey tasting events last year, and we were also happy. We were also very happy to be recognized by the Van Abbe Museum as one of the agents of change in Eindhoven. And this year, lately, I've been busy co-founding a design agency, Code 21. We are focusing on designing climate solutions. And today, I will be sharing with you a design concept that I have been working on under Code 21 roof. It's called Co-Farm, a collaborative carbon farming tool. But before introducing the concept to you, I would like to talk first about some chain of thoughts that I have gone through this year during this 2020. It's about nutrition and health, two topics that I've been working hard on, and the learnings that I gained, and a lot of us learned a lot actually this year because it's been a very big year, 2020. And one thing that I learned was that as a designer, we have designed our lives to perfection. We used precision engineering to achieve efficiency and high productivity in everything we designed. But we realized this year was that our precision engineered and designed products were not designed for resilience, and they could not withstand the shocks like pandemic. And I saw this happening in two areas, the focus areas that I've been working on, the healthcare and the food systems. In the healthcare, which is driven by efficiency and cost, we've been designing for the healthcare focusing on minimizing the healthcare expenditures. But what we faced with this pandemic was that we are facing limited number of ICU beds in the hospitals, limited number of equipments, and overworked clinicians, which is continuously happening right now. There are a lot of overworked clinicians around the world who are struggling during this pandemic. The other thing that we faced as a designer, or my learning as a designer on the food systems, which is also driven by efficiency and cost, we have designed really well complex systems of long supply chains, starting all the way from the food production to the distribution channels, cold storage units, to the retailer services, finally finding our homes. It's a very complex clock working mechanism that we designed. But we have seen different aspects of the pandemic, effects of the pandemic in two different food subsystems. One of them is the food service, and the other one is the retail food service. And they has been affected separately. On the retail side, I would say things have been changing and affected dramatically, but at the same time, things have been changing in a very promising way. For example, with the pandemic, there has been an increase in interest in healthy food, increased demand in fresh produce, local farm stands got busier than ever, local farmers got also busier than ever, and then there was this high demand on community-supported agriculture. And there has been also these growing lists of community-supported agriculture supporters. Whereas on the other side, in the food system for the food service, it has been affected very dramatically, because the food service is not only about the restaurants, as we know, but it's also about the institutional food, all the school foods, all the factory food that we've been eating in our work, in our school environment, also outside of our homes. With the drop in demand, a lot of farmers have faced very dramatic consequences. For example, million tons of potatoes were left over in Dutch farms. Because of the international labor shortages, tons of rotten crops in large-scale farms were left on the farms. And then the EU had to drop food safety controls because of the lack of control staff. And we kept on hearing in the news about the dairy farmers dumping millions of gallons of milk. The perfectly good vegetables were plowed under. Industrial livestock farmers have been euthanizing animals, and chicken factories were facing their hardest time ever this year. And looking a little bit deeper in the topic, because I'm a designer, I just wanted to understand how the system worked. So what I understood is that we are facing this year an enormous amount of waste, which is in the agri-food industry. And ironically, it was designed for high productivity and efficiency using our precision engineering tools. And now we are facing this waste. An example, a very simple example to that, is that the chicken factory, what has been happening in the chicken factories is that the machinery in these chicken factories were designed to process a specific range of chickens. With the drop in demand, the chickens got grown bigger, and therefore they were not able to be processed in these machineries, and therefore they had to be discarded. And a similar case also happened in pig feedlots. With the grown-up pigs taking too much space in these feedlots, the little piglets had to be discarded by euthanasia. Being a designer, I thought, okay, I'm going to look at how these machineries work, and I couldn't help my curiosity, so I just found an example. This is a very simple example to poultry processing machinery, a line. The first thing I noticed here was this terminology. It's an acronym, BPH. I was looking at it and trying to understand what this BPH means. Later I figured it's a bird, it means bird per hour. So this machinery is able to process 2,000 birds per hour, size ranging between 900 to 3,500 grams, and the bleeding time also ranging from 90 to 3.5 minutes. It is well equipped with semi-autonomous tools, such as vent suction units, and then I'm trying to read here, lung suction guns, and also the neck cutting scissors to reduce this fatigue in the operators. And all of this is designed to increase productivity. What we see clearly here is that our food system is based on efficiency and just-in-time delivery. And we also see that we've been doing precision engineering for living things. But living things can't be really engineered that way. Otherwise, we find ourselves backing ourselves into a corner. Are we backing ourselves into a corner by using this precision engineering is the question. And a very good analogy to that is I found the Maslow's hammer theory, a hammer and a nail. If the only tool you have is a hammer, you treat everything as if it were a nail. And I made a little bit of a twist on that, and I want to use it as if the only investment you made is on a hammer, you would treat everything as if it were a nail. And this is a story of our industrial era. We treat everything as if it were a nail because of our huge investment in our hammer. And I have two stories for that. I've been reading this really good book of Michael Pollan, Omnivore's Dilemma. It's a really nice source book. And the story one I'm taking from his book. It's a very very well-known story, and some of that you are probably familiar with it. It's about World War II and the leftovers of World War II. We are still eating the leftovers of World War II. It's about ammonium nitrate. So there was a high investment on ammonium nitrate, as it was an explosive. But then after the war, it found itself in our farms, as nitrogen is a really good source of life. The similar thing also happened with the DDT. There was a high investment on DDT, the poisonous gas, which was used by the military troops to fight against malaria and typhus. And this investment also found itself a new market after the war was over, and now it is also in our farms as pesticides fighting against pests in our farms. What we see here is that we are highly poisoning and bombarding our food today. Every year, 1/3 of our global food is produced using hundreds of millions of tons of nitrogen fertilizer, which ends up in our water, it ends up in our soil, and ends up in our increasing our greenhouse gas emissions. The story two is about how we also cornered ourselves in monoculture. It's about, it's an example, I would like to use the example of corn here as monoculture, but we also know that there are other monocultural agricultural methods and other crops as well. We North Americans look like corn chips with legs. It's a nice quotation from, again, the same book, Michael Pollan's Omnivore's Dilemma, said by Todd Dawson, a researcher in University of California. The story starts with the investment, with the advancement in agriculture, with the development in agriculture. First the horses disappeared, then the biodiversity with the advancement. And the industrial advancement made it possible to do monoculture, to produce only one crop and produce more of it so that we could earn more with one plant. And then we planted more corn to earn more, but it didn't work the way that we expected, so the prices got dropped. So then we ended up planting more corn, the prices got dropped. Then the government came in help to the farmers. They had provided their subsidies and supported the farmers to plant even more corn. The prices got dropped, and then we also ended up with too much corn. So what do we do with this too much corn? And then again, the prices, because the prices got dropped, the technology also came in help. Now we are also designing technological seeds which can also withstand tight plantation and mechanical harvesting, so that we can even plant more corn, which we are right now tight fitting and forcing into new markets. So we have created new markets for our corn. First, we locked our animals into feedlots. They were happily grazing in the fields. Now they are in the feedlots eating corn, facing other problems due to this food. We have been also giving corn fuel to our cars. We've been giving corn as food to ourselves, and we are using corn in other non-food products, like in the construction industry. But today, I will also mention that we are force-fitting corn to ourselves in our food. Everything we eat, from the coffee whitener to the frozen yogurt, to the vitamins and the canned fruits, the tea sweeteners, the salad dressings, they all have corn in it. So we are nailing hard the corn in our food system right now. And we also see that out of these two stories and out of these two examples, that farming today has become use of fertilizers, pesticides, and technologically designed seeds with the help of some loans and the subsidies, it's not also able to withstand and self-sufficiently recycle itself, but it is very much dependent on the subsidies. And the subsidies are used to produce even more so that the farmers can also make a living out of it, but it's just creating more nails to hammer around. And what's the other consequence of this? The other consequence is that monoculture, which has been exploiting and destroying our nature on unprecedented scale. We have lost almost 70% of our biodiversity since the 1970s. The agriculture has stopped being about producing food. It is less about producing and generating food for humans, but it has become more about generating animal food, biofuels, and industrial ingredients. And it has a major role in pollution, with the manure and the chemicals and antibiotics, with the growth hormones, which end up in our water and in our atmosphere. 1/3 of our greenhouse gas emissions come from the agriculture, and up to 30% of it is coming from the food system alone. And 14.5% of it is coming from livestock supply chains. Every 1 degree of increase will reduce up to 50% of agriculturable land, which would lead into scarcity, which would lead us eventually to use more industrial agriculture, to create more greenhouse gas emissions and create more warming, and it would lead us to a vicious circle where we will be ending up in our own extinction. 50% of the planet's habitable area is used for agriculture, and 77% of it is used for feeding livestock animals. And only 17% of it is finding itself in our daily caloric supply. And this is a food that not everybody can afford neither, so it's only a food of a very small percentage of a world population we're talking about. And moreover, what we have also been seeing is that industrial livestock farming facilitates spread of viruses from animals to humans. So here I would like to also talk a little bit more about the food system, but before starting with the food system, a very good example of the meat supply chain, what are we talking about here in the meat supply chain, is that it's a very well precisely designed system. Starting from the farm to create the food for the animals. So from the farm, the produce goes to the storages, from there to the processing units, to the manufacturing units, then finds itself in the feedlots, and then in the sale yards, then the processing units, again to the slaughterhouses, then shipped as chilled or frozen to other markets. And finally, on the other side of the shore, it finds itself in cold storages to be split into retail or the food service and finds itself in our plates. And this is not over, because it also is extended backward, as these also animals are being shipped alive and exported alive from other countries to countries. But this is not only a meat problem, this is also a food problem, because the food supply chain is not that much different. It starts with the farm, but not actually, because every farm is dependent on the seed, chemical, and machinery industry, which also has its own supply chains and its own cycles. So we are ending up with this problem, the food problem, which is our food is too far away from us. It has been touched too many times, visited too many places. It's not healthy for us because it's not healthy for our planet. So it is time to talk about regenerative food systems and not about sustainable food systems, because we cannot sustain this anymore. We need to regenerate. What means regenerate is that we need to regrow, we need to renew, and we need to restore things that has been lost and damaged. And how do we do that? We just look at nature, because nature does this very well. Plants sequester carbon from the atmosphere to grow, and then it passes it to the soil and turn it into life. What it takes a human to make a living ecosystem starting from the damaged soil is not too long, but just maybe more than 6 years or about 6 years. First, we need to stop tilling using this machinery which destroys the soil to increase the microorganisms in the soil. Then we need to bring back the biodiversity and the cover crops. In time, also we need to stop using the fertilizers and bring the animals back in the farms to happily graze around and clean the soil and fertilize the soil at the same time. With the cover crops, use of cover crops, we would be able to retain the water in the soil. And layer by layer in time, we will be working with nature to create an ecosystem which sustains itself. But more importantly, the regenerative food system and regenerative agriculture should bring the joy back to the agriculture, back to the farmer. So the farmers should stop being dependent on the loans or subsidies, but they should be able to support themselves. They should be able to also work for their future and make plans for their own future and use farming as one of their own motivational life source. But more importantly, we need to also make it fun for the new generation of farmers so that they can also start staying in the farms. Another important thing in regenerative food systems is creating the communities which are able to support each other, create a network and also a community, which in time also becomes robust and resilient to other shocks like pandemic. So they can withstand the shocks and they can support each other. So the importance of farm to fork and this connection between the farm and the fork is quite clear, and we have also seen that it's not possible to create this type of connection through a long supply chain. It's very important to bring them together and shorten the distance so that we create a community. It's important to keep farmers in local communities and reduce the time of sales and distribution so that the farmers can only focus on the fun part and the motivational part of their jobs, which is farming itself. And making farming an attractive lifestyle is also very important so that we will have new farmers, new generation farmers in local communities. And in time, it would create microeconomies and it would reduce migration to cities. And also it would limit the breeding grounds of future pandemics and epidemics because there won't be high population of big cities. So we know it's important to create this connection of communities and collaboration between the farmers and the consumers, and this community being able to robustly and resiliently support each other. And how do we do that is a question, but I don't know the answer. I tried to find and explore an answer through a design concept, and I will share that with you today. It's called Co-Farm. It's carbon farming tool, but also a collaborative farming tool for the consumers to create a connection, to have a connection and community with the farmers. What it is about is by being one of the members of this community, you would be supporting farmers, and also you would be growing a farm yourself, watching it grow and become a farm, and get connected to other local farmers and create a network, having a network of farmers from small scale to medium scale, all supporting and connected, supporting each other and being connected. And how this app works is that you would be able to create a virtual farm of yourself made out of building blocks. And these building blocks, each one of these building blocks would be coming from a local farm. Let's say you have some brassicas, some kale, or some legumes, or the aquaculture, the asparagus coming all from connected to a different farm in your local area, and you would be seeing them as their own, as they are all in your own farm. And you would be also seeing where they are actually coming from and which farm is actually producing these produces. Starting with the fresh new page, let's say you are building your farm and you start with an orchard. And you would be going through the available crops, and you will be picking the ones that you would like to have in your own farm. And layer by layer, you will create a produce of orchards and the farm, and you will end up this nice, lush environment of your own. And every week, you will be also recommended of your harvesting times. Let's say you have 12 kilos this year, and 6 of them you would like to keep, and 6 of them you would like to feed back to the community. But more importantly is that also the reduction of the distribution channels. And by the use of community, you can also use carpooling for delivering your, distributing the vegetables. You can help each other, and you can arrange carpoolings. And at the end of the year, you would be able to see your own carbon sequestration per year. And more importantly, enjoy the local food in your home. Thank you very much. And we have come to the end of our presentation. And now
Hey, you're still here. So you like the video. If you want, subscribe and click the bell.